Algebra 1, Section 9.8. We are going out of order here. This will make more sense once we do Section 9.6. Right now, you're going to have to trust me. You need to learn factoring by grouping first, and then there will be some factoring in Section 9.6 where you'll be given a choice to do what is known as factoring using trial and error or using factoring by grouping. But I need to teach you this concept first. And actually, this is, as you notice in the title of the video, this is actually part 1 of 2, because factoring trinomials by grouping will happen in the second part of this section as well. So I'm going to encourage you to stop after this video and not watch 9.8 part 2 and do the homework that is problems 5 through 16. Actually, we're going to do 5 together, but then beyond that through 16, and then pick up and do the rest of the 9.8 video. And then we'll go back and we'll finish sections 9.6 and 9.7. The concept again is called factoring by grouping, and the giveaway that it is a factoring by grouping problem is that there are 4 terms. You'll recall that so far what we factored has been 3-term polynomials. If it's got 3 terms, then very often we can factor it into 2 binomials as a product. Well, if there's 4 terms, as you see in this first example, again, that's going to be kind of the signal that this is going to be factoring by grouping. Now, does it have to be factoring by grouping? If you have 4 terms, it's like automatic? No. For one, you should look for a GCF. The first thing you should look for always is a GCF. Can we factor something out? A lot of times that can reduce that. A lot of times that can change the problem as we're going to see it. You should also just look for like terms. Sometimes you get like terms and they can be combined, and what you thought was a 4-term polynomial is really a trinomial or a binomial. Okay, but if it looks like this, if it's in standard form, there's 4 terms that are all unalike, then it's going to be factored by grouping. And here's how it works. We're just going to practice this a few times. You're going to look at it, and it should be in standard form as this problem is. You're going to look at this as the first half and the second half, kind of the front and the back. And you're going to divide those in half. And locally then what you're going to do is factor using a GCF. Again, we did this a couple of lessons ago. If I remember right, it was section 9.2, where we factored using a GCF. And these two, see, all 4 of these terms, there isn't a GCF for all of them. There isn't a number that divides out of 6, 3, 4, and 2. But there is a GCF here. And not only can you take 3 out of 6x to the third and 3x squared, you can also take out x squared. So the GCF would be 3x squared. And if we divided that out of just those 2 terms, you'd be left with 2x plus 1. Go ahead and take a minute and process that. What I told you when we did GCF factoring is when in doubt, you can always multiply back in. 3x squared times 2x would give you 6x to the third. 3x squared times 1 would give you 3x squared. We basically divided all of what's in 3x squared out, but there's still a placeholder that is that 1. Okay? Now, in this second part, there is also a GCF, and you might look at this and think 2. What you're really going to want to divide out, though, is -2. I'll show you why in a second. You want to divide out -2 so that the symbols inside your parentheses become the same as they are here. Not only is what happens when I divide out a negative, will I get 2 positive values here, they're the same 2 positive values as you have in this set of parentheses. This is the key component to factoring by grouping. Once you do this step that we're in the process of doing right now, you'll have 2 sets of parentheses that are the exact same thing. When I divide -2 out of -4x, it leaves positive 2x. When I divide -2 out of -2, it leaves positive 1. Okay, now again, go ahead and process that for a second. Distribute it, the -2 if you need to check. And it is correct. Now, sidebar, if you had, 3z plus 7z, you've been taught that those are like terms and you have 10z. Okay? If you had 3w minus 2w, you'd go 3w's minus 2w's is 1w, or just w. Okay? Well, that's what we're gonna use right here. You have 3x squared, 2x plus 1s. Now that may sound weird to say 3x squared of them, but that's sort of a possessor there. Here you have negative 2 of the 2x plus 1. 3x squared of the 2x plus 1 minus 2 of the 2x plus 1. Just like I added the 3 and the 7 here, I'm going to add the 3x squared and the negative 2 in its own set of parentheses. 3x squared minus 2 times 2x plus 1. The common question that I get when I do a problem like this is students will ask, what happened to the other 2x plus 1? There were 2x plus 1s, and now there's 1. Well, back to this problem, I shouldn't have crossed it out. I should have just left it there. Back to the problem that is 3z plus 7z. What happened to the other z? Well, no, nothing happened to the other one. They just got combined. You had 3 of them. Now you have 7 of them. Total, you have 10 of them. Here you had 3x squared. You subtracted 2 of them. Now you have 3x squared minus 2 of that thing, that 2x plus 1. Okay? And as I always say, you can always check this by multiplying. I won't do it on this problem, but you'd be welcome to go ahead and multiply 3x squared by 2x, 3x squared by 1, negative 2 by 2x, negative 2 by 1, and you would get what we started with, which is this right here. Note that in this multiplication, you will not have the middle two terms to simplify. Like we often do in a FOIL problem, if you FOILed this, you'd have 4 terms, just like we started with in the problem. Next example. You heard me say a few minutes ago that what we want to do is look for a GCF. That would be paramount here. There is a t that you can take out of each one of these terms, and we want to knock this down. Not only does it make factoring easier, but we will be knocking this down by a degree, which will make it more conducive to factoring by grouping. And also 8, 12, 16, 24 are all divisible by 4. So there's a GCF here that is 4t, which would leave 2t to the third plus 3t squared plus 4t plus 6. When I divided 4t out of each one of these terms, it's like dividing 8 by 4, 2, 12 by 4, 3, 16 by 4, 4, 24 by 4, 6. And by dividing t out, it knocked each exponent down by 1. Fourth became third, third became second, second became first, t to the first became t to the 0, which we don't bother to write because t to the 0 is 1. Okay? And yes, you're going to take the 4t along with you. That's part of the problem. That's going to be part of your solution. Don't lose it. We're going to need that. And then we're going to factor by grouping again. This 2t to the third plus 3t squared has a GCF locally, if you will. Right? So I'm looking at just the front half here. And that number would be just t squared, or that term, I should say, is just t squared. Can't divide anything out of 2 and 3. So I divide out t squared, and that would leave me with 2t plus 3. And here you can't divide out any variable because there's no variable with 6, but you can divide out 2, which would leave 2t plus 3. Now again, it's not a coincidence that what's in parentheses is the same thing. If they're not the same thing, you don't have a factoring by grouping problem because you're not going to be able to combine like terms, so to speak, to group them together. But they are the same thing. 2t plus 3, 2t plus 3. I have t squared, 2t plus 3s. I'm adding that to 2 more 2t plus 3s. That's going to be t squared plus 2, 2t plus 3s. Treat them like objects just as if they were like terms. And then you should also have a 4t out front. This is completely factored. Okay, now there is another concept that we'll deal with in part 2. We'll start up with this problem right here. So we're going to end with that right there, except I am going to do one homework problem with you as well. Strangely, the first one in number 5 in your homework is 5 through 16 as a partial assignment. Strangely, the first one is tricky. So let's just go ahead and do that together too. The process is the same. I'm going to look and see if I can find a GCF in 6n to the third and 8n squared, and that would be 2n squared. And when I divide that out, that's going to be 3n plus 4 Okay, and then as I look at the back half, you got to find a GCF for 3n plus 4. And there isn't one, right? You could look and think that, well, there's no number that you can divide out of 3 and 4. There's no variable exponent combination that you could take out of both terms. So you might think that this is not factorable by grouping, but it is. What you're going to divide out is just 1. In fact, the GCF of 3n plus 4 is 1. And we have to divide out the 1, and you have to show that work because it's going to hold a place when I do the next step and say 2n squared plus 1 times whatever we have. And when I divide 1 out of 3n plus 4, nothing changes. And not only is everything true what I just told you, but again, look at the parentheses. They are the same thing. So then by combining like terms, 2n squared plus 1 times 3n plus 4. Okay. Now again, I would encourage you to not play video 9-8 part 2 and try to figure out all of 9-8 together, but rather go ahead and practice 5 through 16, then go back to YouTube and watch the second video and you can finish the lesson. Thank you.